Hi, Timur. Hi, everyone. Yeah, and then first I want to again thank everyone for helping each other in Slack. That's amazing. Also, yeah, Timur and Thinam for preparing this awesome homework. I think I should go here. Yeah, and also thanks for putting all the questions to the frequently asked questions. I went through the document today and it's really amazing. It's quite well structured and I'm pretty sure many of you use this and it's useful for you. So I want to show now today to talk about this new model that we released a few days ago. So this week we will talk about production ready machine learning. And now I will go to the course page. And yeah, this is this folder. So it's called Production Ready Machine Learning. We released it a few days ago. It's a completely new model. We did not have this model 1 year ago. So if you were taking this model previously, or if you were taking this course previously, this is completely new material. And yeah, so this week we will walk through this model, and it's again focused on deployment. It's very similar to module number 5. In that module, we learned how to deploy a model using Flask and Unicorn and Docker and all these things. And here, so that these models that we, these frameworks, these libraries that we covered in module 5, they are general purpose software modules or frameworks, right? So they are not focused on machine learning. But BentoML, the tool we are going to use in this week, it's focused specifically on machine learning, and it's designed to serve machine learning models. And as you go through the module, you will see how much simpler the process is for deploying models. And how much more performant it actually is. So one of the quite interesting modules here, units here, is this one, high performance serving. But I will not spoil you all the fun. So go through this. And of course, as usual, we have a homework at the end. And then next week we will have a midterm project. So next week we will not be able to have office hours on Monday. But what we will do instead is we will have office hours again this Thursday. So this Thursday, I invited Tim, who is the instructor for this module, and we will answer your questions, and I also will spend some time describing the project, like what exactly you should do for your project. And if you, let's say, already finished this BentoML module, you can already go to this projects folder. I rearranged this, changed the structure a little bit for the repo. So you go to the projects, and in this README, like it describes everything you need to know about the project. We will go over this information again. But yeah, please go through this, and I hope it will be more or less self-explanatory. And if you have any questions about that, please ask in Slack. Okay, but now I think we covered the module. We covered more or less a little bit the project. Maybe one more thing. So many of you were asking questions about the timeline, how exactly the timeline looks like. And I want to remind you that if we go to this 2022 cohort folder, we have here deadline calendar. So if you click on this deadline calendar, you see how the schedule more or less looks like. And you see that BentoML is here. It used to be here. It was module 5.5b. We moved it a little bit. So we swapped places between decision trees and this one. But yeah, it was always there. And now after that, we'll have midterm project, and then we'll work about neural networks. And then after that, 9 and 10 will be focused only on deployment. And then again, we will have more projects and article. And also, we haven't announced it officially yet, but we will have a competition starting from December, ending in January, end of January. So you will learn more about that. Yes, Thursday is the same time. So that we actually, if you also don't know, we have a calendar. in this calendar. Yeah, not this one, not the deadline calendar, course calendar. Yeah. So this is a Google Calendar, and it has all the events, all the meetings, invites, whatever, in form of a Google Calendar. And it already has a meeting on Thursday at the same time, which is for me 5 p.m. Central European Time. Okay, now I think the homework. Yeah, homework is here. So what we will do now is I'll just go to questions. We have a bunch of questions from last time, and I will just go through these questions and try to answer them. Yeah, I see that there is a question about the data engineering course. It does start in January, and it starts in, if you just go to our data engineering course, you will see that it starts middle of January. There is no, yeah, it says 16th of January, which is Monday. So there is some overlap between this one and that one, but if you finish all the activities, like if you finish the midterm project and you finish the capstone 1 project, then you're good to go. You don't need to spend more time working on this project, only if you want. Let's say if you want to work on an article, you're welcome to work on an article, but yeah, if you follow the deadline calendar, you don't have to do project 3. So just 2 projects are enough, and then you can start data engineering Zoomcamp, and there will be no overlap. But yeah, technically there is some overlap. Okay, let's start with the questions. Can you revisit the ETA explanation? I do not understand yet what it means. I think the easiest way to understand what it means is just to try different ETAs and then see how exactly your learning curves, the plots that where you show the performance, how exactly they look like. And if it's too big, you see that your model overfits very quickly. So it reaches on the training set, it reaches 100% performance very quickly, but on the validation data set, it becomes worse and worse. So this is, and it becomes after a few trees, after a few iterations. So it happens very fast. If you set a learning rate too small, then you will need a huge lot of trees to actually have anything meaningful. So it will simply take too much time to learn anything. And then this would be the case of underfitting. So selecting the right learning rate is also some sort of it's trial and error. You need to try different values to see what works best. So what I usually do is I try 0.3, I try 0.1, and then I try 0.01, 0.05. And then, yeah, I just look at these plots, and then based on that, I make my decision. And also keep in mind that when you have a lot of trees, your model becomes slower. You don't want to have a slow model. So sometimes it's better to set the learning rate a bit higher so that you have fewer trees. So it's better. I see that there is a question, is ETA sometimes called epochs? No, ETA is not called epochs. Epoch is, you will see that in the deep learning module. An epoch is typically one iteration over your entire data set. But yeah, I will not spend time now explaining what an epoch is. Maybe when it's time, you check the deep learning video, and if it's still not clear what an epoch is, then we can discuss it. Okay, I hope this explanation makes sense. If it doesn't, again, in the deep learning module, we will talk a little bit about a different concept or a similar concept called learning rate. It's actually not similar, it's the same concept. And actually, there is an entire unit about this called learning rate. And yeah, you can check that. Maybe just check this unit separately from the rest. Maybe it will help you understand ETA a little bit more. Maybe. I started ML Zoomcamp with Windows, and it was difficult in deployment. What is the best system requirement for Section 7? Okay, so for Section 7, Windows should work. I tested it in, I actually tested it in VSL in Ubuntu, but on Windows it should also work. I can, if you want, I can test, but I think that some students already did it and it worked on Windows. Remember that if you do this on Windows, it's actually already in our FAQ. So on Windows, 0000 is not the same as localhost. So you, let me scroll down to this one. And yeah, if you just run bento.ml serve and then the rest of the command, it will say that you need to open this URL. But this URL will not open. You need to replace these zeros with localhost. And actually, yeah, there is already a section in the FAQ about that. Apart from that, I don't expect to have any problems on Windows. So you can keep using Windows as long as you have Docker installed. You should not have any problems. Okay, so I'm trying to parse this question. So with evaluating our model and validation, what to do if our validation model is high accuracy and validation on test is very low? So when you have very good score on validation, but very low score on test, it means your model became lucky. Remember, we had this explanation. So let me go back to the very first module. In this very first module, we had a lesson about model selection. So sometimes a model can be lucky and it doesn't necessarily translate well to test. It happens. What can also happen is sometimes, let me come back here. Sometimes I'm just trying to come up with a good explanation. So sometimes validation and test data sets are different. It means that, for example, if you if you split your data set by time. So for example, you have a data set for 1 year, and then you, for training, use everything from January till, I don't know, September. Then validation is October, November, and test December, right? So you evaluate your model on validation, right? And October, November looks great, but then we know in December it's Christmas time, and then many models that you train during the normal months are different, right? So then for them, this December could be a surprise. So maybe you have something like that in the test data. It's normal. And for these cases, you just need to think like how exactly you can build a validation data set and training data set in such a way that they are similar. So for example, if you have a lot of data, then maybe you can use the one last year for validation or for testing. Right? So something like this. So it's all problem specific. But yeah, usually it's an example of overfitting. Why do we use GUnicorn and not just Flask? So if we just use Flask, then there is this warning that Flask is not a production VSGI server. So what you need to check is what VSGI is, and then you can read about this and it will explain what actually VSGI is. I don't think I'll have time or knowledge to explain it right now here, but the thing is with Flask, it's not a VSGI server, but GUnicorn is. So GUnicorn, well, Flask kind of is, but it's very like a toy server, let's say, just for development. So it will work on your computer for testing only, but it will not scale. It will not be able to process multiple requests coming in parallel. And GUnicorn is much more scalable, parallelizable. Yeah, it's just better to use. So that's the main reason why GUnicorn is needed. And for more details, maybe just check. This article could be a good one, like what is VSGI. and why we need like this application framework, which is Flask, and VSGI server, which is the actual server. Can you give a general overview of what skills a junior data analyst should know? Job postings are confusing as companies seem to have different ideas. Yeah, I mean, I can give you my idea on what data analysts do, but it doesn't mean that everyone follows this idea. So probably you should actually start with job postings and then think, okay, like these are the companies I want to work for. What kind of skills they require, and then go from there. That probably would be more useful than just my opinion. And that it's in my humble opinion, right? But I'll try to answer it anyways. And yeah, so data analysts, they should know SQL very well. So that's their main tool, SQL. Then they should also, and SQL, I don't mean just, I don't know, select star from table. You should also know joins. You should know group by, like having statement, Windows function. If you know window functions, that's great. I don't use, like every time I need to use a window function, I need to Google it, but analysts usually know it much better than data scientists because they need to do SQL a lot more often. Then another tool that analysts need is Python or R. I think Python makes more sense these days, but again, depends on the company. Some companies, analysts use R. And then there it's the usual, like, let's take Python. Now there you need to know tools like Pandas, some visualization library like Seaborn, Matplotlib, yeah, maybe I don't remember what's the name of this interactive library, but if you Google, you will find them. So doing simple analytics in Python and then plotting the results is useful. And then what I also see our data analysts at OLX, we call them product analysts. So what they also use a lot is Tableau or any other dashboarding tool. Again, depends on the company. Many data analysts spend quite a lot of time building dashboards in Tableau. Sometimes it can also be ad hoc analysis in Excel, or first in SQL and then putting data in Excel and then sending it over. So yeah, but SQL, the most important thing, Python and data analytics tools in Python, such as Pandas, and then dashboarding. And that probably covers like 90% of the work. But also it's important for data analysts to be able to communicate. I hope it's helpful. It's a bit off topic, let's say, for this course, and I am not an analyst. I am working with analysts quite often, but I am not an analyst. So please treat this with a grain of salt and maybe talk to a real data analyst about that. Yeah, indeed, in comments I see Plotly. So Plotly is this interactive plotting tool in Python, which is quite cool. And I see many data analysts in the company where I work at OLX. I see many of them use it. Not many, but some use it. Mostly, I think they do this exploration in Tableau more often than not. Okay, so in one of your podcasts, I heard the phrase converting business problem into a machine learning problem. Can you give us 2 examples in brief to understand what it means? Imagine that, like, I don't know, you're running an e-commerce company, or yeah, and let's say simple e-commerce. And then our CEO comes to us and says, our users have big troubles discovering items. How can we help them? And then you need to understand, okay, what does it mean they have troubles discovering items? So you need to understand what are the problems they have, and how can we help solve these problems. And then, yeah, once you understand the problems, then you can generate possible solutions. One of them is, for example, coming up with a good search. Another solution could be coming up with good recommender systems. And then it also depends on a business goal. Like, do we want to, what do we want to optimize? Do we want to make sure that our users buy more, or it's actually easier for them to find what they're looking for when they're just exploring, right? So like this is all input that is coming from, let's say, business people, the stakeholders in the company and the users, and taking all this input into account and thinking, okay, now I know what I need to work on to solve this problem, right? How can it look like? And then the solution could be designing, coming up with a recommender system that is on the item page and then it shows similar pages. Or, for example, showing what people buy in addition to this item too. So that's one example. Another example, I don't know, let's say we have a video hosting, something like YouTube, right? And then all of a sudden people start uploading some content that we don't want to have on the platform. So we need to have some sort of we want to get rid of this, right? So then business comes to us, data scientists or software engineers, and says, okay, like, can we somehow make sure it doesn't happen? And then we can think, okay, like, what are the ways we can make the bad content go away? And then it could be introducing a content moderation platform where we apply some different machine learning algorithms to video to understand that this video should not be on the platform. Or instead of video, it can be anything, right? Yeah, so this process of listening to the stakeholders, understanding what the problem is, and then up to the point where you have an idea how this could be implemented, this is what I call converting a business problem into a machine learning problem. I hope it makes sense now. Somewhere while talking about regularization, you mentioned a mathematical book starting with elementary or elements. It's Elements of Statistical Learning. So let me just write it. Elements of Statistical Learning. Yeah, this is the book, and it's actually free. So if you go, I think like if I click on this link, I get the book. So it's Elements of Statistical Learning. So it's legally free. It's published by the authors for free. And yeah, it's a great book. And for example, we talked about normal equation, right? So I think they start with normal equation. Where is the table of content? Yeah, so this is, it's called least squares. Can I click on this? No? But yeah, so least squares is this, this is what we call normal equation. And they start with that. So they derive, okay, I will not spend time doing this now, but yeah, just check this book. It's quite mathematical, but you might like it. Do you have any recommendation for where to start with NLP? Project-based, hands-on, not full of theories like ML Bootcamp or Zoomcamp. What I personally like is Kaggle. It's not a course, yes, I know, but there you see a lot of different kernels, notebooks that you can follow and try to learn it. Okay, I don't think it answers your question. I'll give two recommendations. The first recommendation is go to our MLOps Zoomcamp, and then I think in cohorts, in this one, 2021, in the midterm project, we had this 3 office hours. During these office hours, I showed some extra stuff, and I think during one of them, probably it was 9. Is it 9? And let me see. So in 9, no, it was probably 8. Yeah, I showed how to deal with texts. So if for your project you're going to use text, then check this, check this notebook, check the corresponding video on how you can quickly incorporate text in your machine learning models. Yeah, this is a relatively simple approach. Then there is a good book called Introduction to Information retrieval. Yeah, this one. This is a very nice book. It's also available for free. It's relatively old. You see, it's 2006, but it's a very good book. It's quite practical. And yeah, it talks about search, but many of these things are applicable to machine learning. Like, for example, this vector space classification. Yeah, this is for text classification and naive Bayes. Yeah, not all is relevant for NLP, but some things are. So, for example, like index, construction, compression. This is more relevant if you want to learn about search. But some of the things like how do you break down like string into tokens, into words, like what are the methods there? Yeah, I think it's a good one. There is also, I think, called taming text. But I think it's in the examples are in Java, if I'm not mistaken. Yeah. So maybe it's a bit old. Are they in Java? Maybe I can quickly check. Yeah, looks like Java, POM XML. So this is Java. Yeah, Kaggle probably is good. If you saw, I recently asked a question in general, what kind of courses you want me to work on, or course. So maybe you can write what exactly you want to know about NLP. I know some stuff about classical NLP and information retrieval and search, but I don't know much about modern NLP, like all these transformers, GPT-3, all this kind of stuff. BERT, like all this, I don't know anything about this, to be honest, so I won't be able to actually do a course about that. But yeah, please go to that thread and write what you have in mind. I missed last two homeworks. Can I still catch up? Can I still get the certificate? Yes. So I'll remind you that homeworks are not required to get a certificate. You need to pass 2 projects out of 3. And if you do that, you will get a certificate. What it means is right now, you can actually, the important part for the project is knowing how to deploy a model. So that you will have to catch up if you want to pass your project. If you don't catch up right now, you can spend the time we allocated for midterm project for doing this. And then you can work on project Capstone 1 project and Capstone 2 project, and then submit these 2 projects and then pass the course and then do the certificate. Right? So you don't have to do everything in this course. So for example, even if you don't learn what we study like TensorFlow, and if you don't learn Kubernetes, you can still do 2 projects and then pass the course. Right? But what you need to learn, what you have to learn is deployment chapters, right? Deployment sections. Without them, you will not be able to finish the course. And yeah, so chapter 5, definitely. 7 also helpful. And 7 builds on 5. And in my opinion, 7 is actually easier. So once you know the foundation from 5, taking 7 and then applying this is actually easier. So you will need to do less work if you use Bento compared to Flask. Yeah, so you can use Bento for your project, and I do suggest to use Bento for the project. Then also we will have a chapter about serverless deployment and then Kubernetes. It's up to you whether you want to take them or not. I do recommend to take them, but use your own judgment to understand if you have the energy to actually do this. Right? I know some people sign up for this course just to do this Kubernetes module, right? And there is nothing wrong with that. But if for you, chapter 5, module 5 was difficult, maybe Kubernetes would be even more difficult. So maybe you can focus on something a bit simpler, or there's no harm in trying, right? So I would still suggest to try Kubernetes. You will have quite some time for the Kubernetes homework. It will, according to our schedule, it will actually be scheduled over the holidays. So you will have quite a lot of time to finish it. Well, let me check. So I think for Kubernetes, no, not for Kubernetes. That's for the, but yeah, I think for Kubernetes, it was last year that it took a bit more time. So we actually left the submission form open for quite some time. So people who need to catch up did this over the holidays. So yeah, don't worry. You'll be able to catch up. But the important thing is focus on the deployment modules. It will help you with the project. How to explain in simple words to stakeholders what is machine learning and neural networks? Well, that's why we have module 1. There, like the very first unit, the very first video, this example with cars. Just use this example and you can use that to explain what machine learning is. When it comes to neural networks, we have module 8 about neural networks, and then you can use that to explain what a neural network is, right? But if you want to one sentence explanation, it's a bunch of algorithms that extract patterns from data. I don't know, will it make sense to your stakeholders? If it will, good. If it will not, then you have these other resources that I mentioned. You have consistently used predict proba instead of predict for the models from scikit-learn. Is it because you wanted to use AU, AUC, RUC? Yes, also because of that. But usually, typically, I am more interested in probabilities than in hard scores. Because for example, yeah, we have this model that we just studied, risk score, right? So instead of just saying, okay, this user is going to default, this client is going to default, it's much, much more useful to know what's the probability that this user is going to default. Like how likely, how risky this customer is. So we have a number. It's not just binary, okay, risky or not risky. There are multiple gradations of risk, let's say. So there could be completely not risky, somewhat not risky, moderate, somewhat risky, and risky. Let's say could be 5 gradations or something like this. So then it's more granular for people to make the final decision to decide, okay, should they give the credit or not. Increasing an estimators gives better AUC, but also increasing AUC range between Xtrain and XWell. Can you give your opinion, please? By increasing AUC range, you mean that the gap between Xtrain and Xvalidation becomes wider. I would not worry about this too much as long as your score on validation is good, and then you're certain that your model is not overfitting, then it's fine. Right? So oftentimes I don't even look at training score. No. Yeah. Okay. This thing got me distracted. Yeah. So that's fine. As long as your validation is good and you trust your validation, then it's fine. If you have, if you're uncertain about your validation, what you can do is you can run cross validation. Right, and then if you have 5 scores instead of 1, and you can see standard deviation of these scores, you can be more certain that the model is behaving or not behaving well. So yeah, pay more attention to validation rather than train. Yeah, happy to hear that. And to hear that. How often do you use hypothesis tests and p-values in your real data science job? Quite often. I don't use them personally. We have we use them for running A/B tests. So imagine that, yeah, let's say we want to. So let's take this churn example, churn prediction example, churn detection. So we have one model for detecting churn, and then we will roll out a new model. And our ultimate goal is increasing revenue, right? So what is our revenue in 1 month, right? So From these experiments, we know that our model has this precision, it has this recall, it has this AUC, it has blah, 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 like all these metrics, but we don't always know how exactly these numbers translate in real revenue at the end to like how much money the company will have, right? What we can do is we can take these two models and then apply some of the customers, send some of the customers to the old model, variant A, and new, like some other customers to variant B, the new model. And then you can measure what will be the revenue after, let's say, 1 month. And that would be a test, a hypothesis test. In this case, I think it's a t-test, that checking that the means are significantly different between two groups. And then p-value would tell you if you should reject this hypothesis or not. Like, is this new model is actually better or they're the same? But I don't sit with pen and paper and calculate all these p-values. There is a statistical engine that does that for us, right? And of course, there are t-test doesn't always work because it assumes that like there are some assumptions about this, like it needs normal distributions. I don't remember. And then like the statistical engines usually select the best test for a particular situation. Maybe I will recommend you to check in our channel. We have A/B tests. We have actually 2 talks about this. So, even 3. But I was thinking about this one, setting an A/B testing framework from Agnes. So Agnes is my ex-colleague. We used to work together at OLX, and she describes the framework we use at OLX for doing this, for running these A/B tests. And then this one is also like a conversation with Jakob about how they, in his company, they run A/B tests. And this one is more like Sadik is showing how to set up the infra for doing this. It was a few weeks ago. Many of you probably must have seen it. Yeah, so I was referring to this one. And actually this one, Growth Book, is another interesting one. So they don't use traditional statistical tests. They use Bayesian tests. And it's an open source library for doing this Bayesian A/B tests. So you can check that out too. Oh, wow, we have so much stuff. Okay, yeah, check this out. You'll find a lot of useful stuff. But yeah, the answer is yes, that happens often. But it's not something that, yeah, sometimes it's actually during the interview these questions come up, but not for ML engineers. I think data analysts and data scientists need to do this kind of things more often than ML engineers. When it comes to a simple decision tree versus a logistic regression, how can one decide which model to apply? Is there something in the data that tells us that one would work better? Yes, there is a thing called validation data set that you can use to guide your decision. That's the best way you can do, the best thing you can do. Another thing you should take into consideration is time. So to fit, let's say if we have a lot of categorical variables, then fitting a decision tree will take more time than a logistic regression. And then applying it will also take more time. So maybe this is something you should also consider in your experiments. But at the end, you probably want to use the validation set to guide you. How to do the decision tree? How do the decision trees decide the split feature? There is a lecture about that. Just go and check this lecture. I think it was a decision tree learning algorithm. And that module, that the unit describes how exactly this happens. I mean, there are some simplifications, but overall the algorithm is what I described in the video. In which cases should we apply logarithm to the target variable? Yeah, maybe go check module 2. We talked about that, and I think during office hours we also covered that. I don't remember, to be honest, what I answered there, but usually when you have a long tail that goes to plus infinity, like I mean to the right, then this is when you want to apply a logarithmic transformation. And you don't usually have negative values in your original data. So this is when you use it. What happens if we give vectorizer unsubmitted information? Unsubmitted, you mean unseen information? Ignore this information. Yeah, you can. So one thing you can do is you can ask the vectorizer to raise an error. So it will say, okay, I have not seen this value before. Let's throw an error. And this is what it will do. A better thing would be to use pydantic and bend2ml. So in bend2ml, you can include this, where it is. Let me just find it again. So one of the modules this week is talking about that. It's called validation. So here, team is showing how to add a pydantic class. So pydantic is a special framework in Python that shows that that can validate your data. And then this one here, we show how to add this validation to the input data. And actually, in the example, he just removes one of the fields from the request, and the model is still working, right? It's not throwing any exception, which is not always what you want, right? And then in that module, we discuss how to deal with this. Maybe we will see time series in some module, or could you recommend a book for this topic? This comes up pretty often. I mean, first of all, I will recommend to go to our channel, and you will see this talk from Kishan. Wow, so many views. But yeah, and actually in this talk, I already see a book I was about to recommend, and this book is called this Forecasting Principles and Practice. This one. So this is the book you want to read if you want to learn about time series. It's in R, but that's fine. So many of these things, if you are doing time series, you probably want to stick to R anyways. But many things work in Python too. And for example, this exponential smoothing, you can implement it in Python yourself. And this is like the easiest, the most simple, in my opinion, the most simple method for doing time series forecasting. Yeah, and you can implement this, and it's actually quite fun to implement this and to tweak it to see how it works. So if you have some time and if you want to learn more about time series, so try to implement this exponential smoothing. Yep. In credit scoring data set, if I'm not wrong, when we were splitting with decision tree, when seniority was high, it tended to more to default status. Anomaly? I guess no. That's the process of learning. Yeah, maybe like more senior people don't. Yeah, I see where you're going with this. So like senior people are not supposed to go bankrupt and default, right? And they're probably supposed to pay back the debt. I guess this is the particularities of this data set, I assume. But yeah, indeed, it's probably a data issue, or just not issue, but characteristic of this data set. Does predict proba give out real probabilities? Not always. For logistic regression, it does. For decision trees and random forest and XGBoost, not really. And then there is a thing called calibration. Scikit-learn calibration. So you will need to check this out to see, yeah, this probability calibration. And it shows, I think there are also examples how to do this with random forest. If you can't find examples here, there are examples on Kaggle. But practically speaking, I don't remember last time I needed to use something like this. It's helpful when you want to train multiple models, and let's say you've been using logistic regression in production for some time, and then you make some decision based on this threshold. but then you want to deploy a new model, XGBoost, right? And you want to make sure that the ranges you have in the previous model are the same in the new model, so the distribution look kind of similar, right? So this is where calibration helps. Yeah, so it's a useful thing, but not every application needs it. Alexei says, not surprised that XGBoost model is the best for tabular data. What is the alternative type of data if it's not tabular? Images data, text data, time series to some extent. Oh, it's tabular. Yeah, but like, okay, images and text are mostly, they come to mind when I talk about non-tabular data. And then in module 8, we will see what to do with images. And with NLP, yeah, you can check it out. There are a lot of resources on the internet how to use neural networks or how to use other, because if we used like traditional methods like count vectorizer that I showed you in the office hours, it will still take non-tabular data and turn it into tabular data. But with neural networks, it does a bit more than just that. It's more complicated, more advanced. Yeah, so you can find a lot of examples on the internet. What is the most terrible errors that data scientists could do nowadays from what we should be informed about? I think the most dangerous one, or I can think of two, is going for the most exciting and complex model when a simple non-machine learning solution will work. Like, for example, you can just calculate, do something like group by and calculate mean for each of the things to, let's say you want to predict the price of a car, right? So what you can do is you can run a group by query from your data, and you can look at the model, make and year, do group by, and then use this as a prediction. That's very simple. It doesn't need any machine learning at all. And then it's already a good baseline. Then the logistic regression model that we covered, it's another good baseline that will probably improve over the previous baseline. And maybe that's enough for a start, right? You don't need a complex like XGBoost model or complex XGBoost model maybe is not that complex compared to deep learning, right? But it's very tempting to go with a fancy new solution and skip the boring ones, right? The group by one, the logistic linear regression, decision tree, right? To skip them and go to the more fun ones. So that's something that data scientists sometimes do. Then another one is, what else could it be? I think that's one of the, yeah, and then chasing new tools again, instead of focusing on the business problem, like trying new tools. And I think it's common across all engineers, not just data scientists, but also, software engineers, front-end engineers, and so on. And then I would again go to our channel. And what I will type here, there is reasons your project fail. So there is a talk by Elena, how your machine learning project will fail, where Elena is talking about many different reasons, like how things can go wrong in a machine learning project. And then this one is somewhat similar, but here Duke is talking about search projects, not just machine learning projects, but search in general, specifically search. And this one is more generic. So yeah, check that one. Yeah, I think that's like I covered the most terrible air quotes one. Since wait reserve works on both Windows and Linux, isn't it a better idea to use it instead of GUnicorn? Yeah, like if it works for you, use it. I don't mind. Why does R have a better stats reputation? For historical reasons. So they they have been around in this area, in this domain, longer than Python. Python is, let's say, only relatively recently broke into this data world. Before, before it was not used for data. And I think my why I think it became popular is because of IPython and Jupyter notebooks. You could very quickly experiment with things, and for traditional or for usual software engineers, Python is closer than R, and that's why I guess they started to use Python more and more often, and then good libraries appeared in Python, and slowly Python overtook R. But because it was probably like more for engineers, then engineers are not very good at statistics. Typically, that's why I guess all the stat packages are still in R. Of course, there is how do you call it? Stat methods. Stat methods. Python. Yeah, what's the name of this library? I don't remember. I remember that the abbreviation is SM. Okay, you'll find it. Maybe somebody in the live chat will write what's the name of this package. No. Please briefly explain what to expect with recommender system coming up in project of the week this week. How does it work? I want to follow along observing. So I'm glad you asked. Let me go to project of the week. So project of the week has nothing to do with the course. I mean, to the extent that it's just different initiatives that are run in our community. So we have a course, we have also project of the week, we also have webinars, we also have podcasts. They are somewhat, they are different activities, right? So for the project of the week, this week we'll have a project about recommender systems. And the idea there that every day you get a set of tasks. So then on Wednesday, you get this set of tasks. So you need to come up with an idea. You need to find a data set for this idea, and you need to share your progress. Then on day 2, you will need to go through these suggested materials, also find out some of the materials on your own, and do these things. So learn about the basics, this one, do exploratory data analysis, understand this data that you found, and gain share progress. And you see, every day you get a set of tasks and you need to do them. So it's not like we're telling you exactly what to do. Like, okay, like in this Zoomcamp, right? In the videos, we tell you that this is the exact sequence of actions you need to execute, and this is the result you get. But here it's more independent, right? So we just give you 4 bullet points, and then it's up to you to actually do these things. And then, of course, you share progress. And then here, the idea behind this project is at the end, you have a project that you can add to your portfolio, right? So this is not a project that you just, let's say, took from a tutorial and followed along, but this is a project that you did with some guidance, right? So these are 2 very different things, and that's the idea behind project of the week. And actually, for the project that we will have as a part of the course, the idea is somewhat similar, except you will get less guidance. You will have more independence, let's say. The guidance we have for the project in the course is in form of a criteria, a bunch of criteria that you need to, let's say, satisfy. And then it's up to you to come up with a plan. But here, for project of the week, we have a suggested plan that you can follow, and hopefully at the end come up with a result. And then keep in mind that this project of the week, it's something that so things might not go according to the plan, and it's fine, right? This is just a suggested plan, and we don't know if it's actually will work like that day by day, but it's more like just to give you a guidance. But yeah, up to you how exactly to approach that. Yeah, so there is a comment that I did not know about this. Yes, we have a channel in our Slack. It's called Project of the Week. and it starts this week on, was it Wednesday? And then you notice that there is this letter or digit 1. So we will have follow-up project also about recommender systems. And if you want to take part in this, take part, I mean, propose your own topic. For example, some of you were asking about time series, some of you were asking about NLP, some of you were asking about, I saw in the comments in live chat, Daniel mentioned audio. Yeah, stats methods. Thank you, Aman. So yeah, if you want to learn any of these libraries, we can do a project of the week to learn these libraries or methods or approaches or whatever. Yeah, I hope it was useful. Okay, let me see how much time we have. I don't know, what happened to Zillow failure? Is it a data science case? I don't know much about this. To be honest, yeah, I didn't. I know that their model for predicting the price of real estate went rogue. So it started predicting some. Yeah, I will not say more because I'm not super sure what exactly happened there. I wasn't really following. I know that the company lost a lot of money because of a rogue model. So yeah, I think if you just Google that, you will find an explanation. What do you mean for decision tree and XGBoost probabilities is not real probabilities? What are they then? Are they related? Yeah, so the way decision tree computes probabilities, air quotes, well, scores, is it looks at the leaf, and in the leaf, it sees what is the proportion of the customers, let's say, who defaulted, right? And then this is the score. But this score does not necessarily represent a good probability from the theoretical point of view. From practical, it's fine, but from the theoretical point of view, there are some issues, let's say. And then please refer to this calibration stuff I referred, because I'm not ready to talk in more details about this right now. So for simple projects, I think you'll do fine with just using the output as is. Sometimes, as I said, your business requirements might require, this calibration that the output is consistent and it's real probabilities. And real probability, remember the definition of probability from the probability theory, which is how likely a thing is to happen, right? How likely if I take this client, how likely this client is to leave. And the output of a random forest might not be exactly this likelihood. It might be a score that you can use to understand the relative risk of this customer to default or not, or client, but it's not exactly a probability in the sense from the probability theory point of view. How does XGBoost or LightGBM improve the last tree and build a new tree and so on? Yeah, that's what the lecture was about, wasn't it? I don't go into details about that, and the theory is quite complicated there, to be honest. But I think if you Google for gradient boosted trees paper, there is a paper that, let me check, not this one actually. I cannot find it. Maybe this one. There's this guy. Yeah, this one. Gradient boosting machines, a tutorial. So this thing describes that it talks about derivatives in the functional space. If you're into this kind of stuff, you can check how exactly it's working. But if you're not, don't worry. You can just skip that and focus on improving your validation score. But yeah, this is how it works. So let me show it one more time so you remember. So it's Gradient Boosting Machines, a tutorial by Alexei Natekin and Alois Knoll. Okay, Maybe there are videos or material on the channel about graph algorithms or case studies with network analysis. Yes, I think so. There was a talk about graph analytics. So let me just put graph here. And we had two actually, getting started with network analytics in Python from Eric, and then modeling the human brain by Jesse. So these two are, funny thing that YouTube found it, even though it actually doesn't mention the word graph here in the title nor in the description. But Jessie talks a lot about graphs, and it's actually her research area. I think she graduated already. She has a PhD now. She was talking about her PhD project. And we also had a book of the week about graphs. Graph. Oh, so many. So I was talking about this practitioner's guide to graph data. And then you can see all the questions and answers that we asked. And then this book, you can check this book too. I think it's this book is more about graph databases rather than graph learning. Yeah. You're more than welcome. So yeah, I think it's time to actually wrap it up. Yeah, it's quite, it's getting darker outside. So yeah, it was fun. So this link for questions remains active. So if you have any questions, let's say you watch this in recording and you have a question, just go to this link, Slido link, ask your question. And then remember that next time we meet is on Thursday. So I'll try to get Tim on in the office hours, and he will answer questions about Bento. And if you have questions about career-related questions that you want to ask Tim also, you can think of these questions. And next week, we will not have office hours, and the week after, we will also not have office hours. So I will be glad to answer questions in Slack. Maybe we will also can do it asynchronously if you have a lot of questions about your projects. But I will be away, so I will not be able to have them on the regular Mondays. Yeah, that's the plan. So have fun with Module 7, have fun with your projects, start thinking about a data set you're going to use for the project. And see you soon. Enjoy learning. Goodbye.